Hi guys, this is for related rates with Charity Coombs. So first I wanted to start off by explaining what are related rates. Related rates usually have to do with two or more variables that both increase at the same time but not necessarily the same rate. So one must know how these variables are related in order to proceed with related rates. A key idea is that if you know that the rate at which one variable is increasing as well as the values for other variables, then you can figure out the rate at which other variables increase. Usually, as we learned in Calculus 1, this is done through implicit differentiation and we differentiate in regards to time. So some examples include that the variable of x derived equals to dx over dt, y is dy over dt, height is dh over dt, area dA over dt, volume dv over dt, and radius dr over dt. So I really like ice cream, and my example is Universal Studios is offering a gigantic ice cream cone that has a radius of 6 feet and a height of 18 feet. When given to a customer, it begins to leak through the bottom and is leaking at a rate of 3 feet per minute. What rate is the ice cream leaking through the cone when the ice cream depth is at 8 feet? So we have known values of height of 18 feet, radius of 6 feet. The derivative of height in regards to time, which is 3 feet per minute, and we're looking for the derivative of the volume in regards to time. And so pictured here is our diagram labeled the height of the cone and its radius. The volume equation that we're working with is V equals 1 over 3 pi r squared h. And a key part of this problem comes along. We want to substitute variables so that when we're deriving, we're able to fill in the variables. Using similar triangle theorem, we find that 6 over 18 equals r over h, and when we solve for r, we get that r equals 1 over 3h, and we substitute that into the original volume equation, which leaves us with v equals 1 over 3 pi times 1 over 3h squared times h, which simplifies into 1 over 27 pi h cubed. When we're finding the derivative and substituting after the aforementioned steps, the formula that we're working with is v equals 1 over 27 pi h cubed. V becomes dv over dt on the left side of the equal sign, and we bring down the 3 and multiply it times 1 over 27 on the right side of the equal sign, turning that fraction into 1 over 9 since 3 over 27 is equal to 1 over 9. We also subtract 1 from 3 in the exponent and leave it as 2, and there's a dh over dt as we took the derivative of h in regards to time. We're left with dv over dt equals 1 over 9 pi h squared dh dt. Because we're missing the value dv over dt, this is what we're solving for, so then we substitute in our values. 1 over 9 pi times 8, since that's the depth that we're working with, squared times 3, which was the rate at which the height was changing, and this simplifies out to 64 over 3 pi. And now using related rates, we have just solved for dv over dt, which equals 64 over 3 pi feet cubed per minute in this particular example. Thanks, guys.